So let's take a look at some of the biological components, and you are going to recognize several of these terms that we're going to be looking at. So the first part we're looking at are explicit memories, and the explicit memories are going to be those that are within our conscious awareness. So here we have the hippocampus and we have the frontal lobe that are going to be a part of the explicit. So the hippocampus is going to help encode and get that information into our brain, and then we have the frontal lobe. We also have several association areas throughout the brain, so we can't just say that the frontal lobe is the only place where memories are stored because that is not the case. We have association areas, let's say in our occipital lobe. So then when I see a face, okay, a specific part of my brain is going to help remember faces, for example. Okay, we also have implicit memories, and implicit is below our conscious awareness. So it's we don't really have to think about it. So when I'm talking, I'm not thinking about how to form the specific word. When I'm writing something, I don't think about how I have to write the letter. I just kind of automatically do it. So if you can think of implicit as more automatic, and we have the cerebellum and the basal ganglia. So the cerebellum is where information is going to be stored for our procedural memory, so like riding a bike, writing, and the basal ganglia is also going to help with motor movements as well, or motor memory, excuse me. Okay, so what else do we have to look at here with the biological components of memory? And we have looked at this already, how emotions are going to really enhance our memory because you can notice here that the amygdala is right next to that hippocampus. Okay, so that amygdala is going to be that emotional center and it is near the hippocampus, so it's going to help encode. And these are going to be called flashbulb memories. So, a flashbulb memory is something that we remember in vivid detail, and often it is a highly emotional experience. So, for example, my flashbulb memory is definitely 9/11 because I can remember exactly where I was, exactly who told me. So we do have generational flashbulb memories. So we could think about, like the JFK assassination would be a flashbulb memory, like generational for a generation. The Columbia space shuttle exploding, that would be another generational flashbulb memory. And then 9/11. So what else is going on with the biology? And we actually have to look at the neural activity here. So, what we have here with the long term potentiation is this is the actual physical change of the neurons. Okay, and it's going to increase in the cells firing. So, I really love this picture because it shows us clearly how the cells are changing with repeated stimulation. So this part here with this kind of peak and then how it descends is looking at the actual firing of the neuron. So here it's only firing at this level, and you can see how much after a week the neural firing has increased. The other part that I really like about this with this long-term potentiation, here we can see that we have 5 vesicles that have the neurotransmitters and 3 different receptor sites. After repeated stimulation of a week, we now have 9 receptor sites, or excuse me, vesicles, and 5 receptor sites. So we can actually see how there's an increase in neurotransmitters, there's an increase in receptors, allowing for more firing. Okay, and this is the neural basis. So we're actually looking at the specific neuron. So when I talk about strengthening those neural pathways, and if we were to look at a brain where we have thicker synapses compared to other areas, this is what's happening here. Okay, there's an increase in neurotransmitters and increase in receptor sites. Okay, so now we're going to look at the memory storage systems. Okay, so we have already talked about sensory memory, just in a generally from the first part of the lesson. And what sensory memory is a split-second holding tank. So when we did the activity with the 9 different letters, and then I said top, middle, bottom, that was looking at how your sensory memory stores that information. An example here that you can write down for iconic. Okay, so iconic memory is going to be seeing a picture. Okay, so if you think about that, you see icons, and your brain is going to hold something for about a quarter to a half second. Now, most of what we see, we don't actively process, it does not get into our working memory. But an example of iconic would be to look around at something and then close your eyes. You can still see what you just saw. Okay, so if I'm in my classroom and I'm looking at the Bobo doll, that clown that I have in my room, I stare at it, I close my eyes, I can still see the clown even though my eyes are closed. Okay, and then we have echoic memory, which is about 3 to 4 seconds. And my favorite example for this is when you are essentially spaced out. Okay, so this always happened to me like when I would be getting lectured by my dad. And my dad would be talking to me and I kind of zone out. And then he's like, "Are you even listening to me? What did I just say?" And then, like a boss, I repeat back exactly what he said, even though I wasn't paying attention. And that's because I basically have this brief recording we have this brief recording in our head that because it's like, oh, I have to pay attention to it now. So, what was just said, I can access that information. Okay, we're also going to spend some time with short term memory and retaining information. Now, the thing with short term memory is that it is limited in duration and capacity. And I am going to talk a little bit about working memory here, even though you are going to be doing a TED Talk. And I'll tell you a little bit more about that in just a minute. Okay, so our short term memory is limited duration and capacity. So, what does that mean? It's definitely longer than sensory memory, but I can hold a certain amount of items. Okay, so that would be capacity for a certain amount of time. Okay, so that would be the duration. Now, our working memory is a little bit different because it not only retains the information, but it uses the information. Okay, so this is where we're going to be doing our problem solving. When I'm carrying on a conversation, I think about what I'm going to say next. Okay, and that's our conscious active processing, and it encodes and retrieves in comparison to just short term memory that's going to retain that information for us. Now, what you're going to do, I would encourage you to do this now, okay, and then come back to this lesson, but it's totally up to you. You're going to watch a TED Talk on how your working memory makes sense of the world. And this is a short TED Talk. It's only about 9 minutes. I really like the speaker, and I just really like the information that he presents on working memory, because working memory is really changing a lot. Like when I think back to when I was started teaching psychology 15 years ago, this isn't something that I emphasize as much as I do now. Okay, so there's been a lot of research, a lot of findings that have been happened in the last couple decades. So now would be a good time to watch that. But if you'd rather go through this video and then go back and watch the TED Talk, that's fine too. Okay, and you do have some reflection questions on your FAST assignment. Now, we are going to do a short term, so not a working memory activity, but a short term memory activity. So you need to get out your scratch sheet of paper, and I'm going to read a list of numbers aloud, and I will say ready, okay, and then I'll read the numbers, and then when I say recall, you'll write down as many numbers as you can remember. Okay, so this is going to be looking at the capacity and duration here. Okay, so you have your sheet of paper. Okay. So I'm going to start with like 4 digits and then work my way up. Ready? 9, 7, 5, 4, recall. The answer is 9754. So that was 4 digits. Let's move on to 5 digits. Ready? 6, 8, 2, 5, 9, recall. Six, 8, 2, 5, 9. So 5 digits, 6, 8, 2, 5, 9. Let's move on to 6 digits. Ready? 9, 1, 3, 8, 2, 5, recall. The answer is 9, 1, 913825. So again, 913825. Let's move on to 7 digits. Ready? 5, 9, 6, 3, 8, 2, 7. Recall. The answer is 5963827. 5963827. So if you haven't gotten the last couple, okay, so once you don't get like 2 in a row, so if you didn't get 6, you didn't get 7, you can just fast forward and I'll to the next part of the lesson. But those of you who are still going strong, let's go ahead and continue with 8 digits. Ready? 8, 6, 9. Let's move on to 9 digits. Ready? 7, 1, 9, 3, 8, 4, 2, 7, 3. Recall. The answer is 719384273. 719384273. And if you're up for it, let's try 10. Ready? 9, 1, 5, 2, 4, 3, 8, 1, 6, 2. Recall. The answer is 9152438162. Last activity that we just did with the short-term memory was definitely looking more at short-term not working because we weren't processing the information. We were just looking to see how much we had stored. Okay, so for long-term memory, we're going to be moving on now to that third kind of area. And long-term memory is theorized to be unlimited duration and capacity. Okay, so if I forget something, we'll be looking at forgetting in the next lesson. There's a variety of different things like a retrieval error or it's like stuck in there, would be another way of saying that. So we do have 2 types here, and I had mentioned this earlier when I was looking at the biological components. So here we have a little bit better definition. So our explicit is going to be our conscious awareness, and we have 2 different examples here. So we have episodic is going to be our personal events. So I always think of this like the personal episodes of my life. Okay, and then the semantic is going to be facts. So an example here for personal events: what did you do on your 16th birthday? Okay, that would be an example because it's unique to you. Where semantic is more of our shared knowledge. So, like, what is the capital of Wisconsin? Like, northeast, southwest, like, what directions would those be? Those are going to be examples of semantic because they are facts. Okay, so explicit is what we have to consciously think about. So, if I'm thinking about, like, you asked me what I did on my 16th birthday, I know that I'm thinking about what I did on my 16th birthday. Okay, and this is largely the hippocampus. Now, implicit is going to be our unconscious awareness, and this is known as procedural memory, which is going to be our skills. So, an example here of the procedural memory would be walking, riding a bike, reading, writing. Now, some of these things are going to start out as explicit. So, if I look at a kindergartner who's learning to read, okay, they are definitely consciously aware of sounding out the words, okay? But once we get practice, 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 it becomes procedural, it becomes implicit. And this is largely going to be stored by our cerebellum. Now, I chose this chart on the right because I really like the diagram. So, explicit versus implicit is definitely a confusing pair. Okay, so this is helpful, okay, when we're looking at the memory process. So, I would encourage you to write this chart alongside the notes that you just did or below the notes that you just took. Okay, and finally, how can we remember that the hippocampus has to do with explicit and the cerebellum has to do with implicit? So this is not something that you have to write down, but it is something that is a making it meaningful for us to remember. Okay, so the memory storage here, if a hippo is on campus, he has some explaining to do. So hippocampus is explicit, hippo explaining. And then the cerebellum with implicit, Sarah the ballerina is impressive. Okay, so cerebellum, Sarah ballerina is impressive.